Good morning, dear children. So, today we'll be learning how oxides are formed on heating a metal carbonate. How oxides are formed on heating a metal carbonate. So, I have said you already that metal oxides can be formed by heating or without heating a metal, or by heating metal carbonates or metal nitrates. So there are three ways of making oxides. Number one is heating or without heating a metal. Number two, heating a metal carbonate. Number three, heating metal nitrates. So here in this activity we'll learn how metal carbonate on heating gives oxide. Take some copper carbonate, a green solid. Copper carbonate is a green solid, and you need to take this green solid in a hard glass test tube. Why we are choosing hard glass test tube? So that on heating it do not break. Otherwise, if there is a soft glass tube, it may break on heating. So we'll take hard glass tube which resist a lot of heat, which do not break on heating, and heat it for some time. Then what will happen? So you can see here a colorless carbon dioxide gas is coming out on heating copper carbonate. So on heating copper carbonate, what happens? A colorless carbon dioxide gas comes out, and at the bottom what is left? Black solid residue. So initially it was a green solid, but now it is black solid. That means a chemical change has taken place, which is characterized by change in color. So as I said, what you will observe that the green solid changes into a black solid. That means change in color is a characteristic of a chemical reaction. Also, a colorless, odorless gas is evolved, and this gas, the gas which is evolved, if you pass it through lime water, then the colorless lime water turns milky. So if colorless lime water turns milky, then you can be sure that it is carbon dioxide. The gas you have passed is carbon dioxide. So the gas evolved is carbon dioxide, and the black residue is copper oxide, a metallic oxide. So what was our intention? Our intention was to make metal oxide from metal carbonate. So on heating metal carbonate, we are getting metal oxide. We are getting oxide or metal oxide. So what happen is, when we are heating green color copper carbonate, then we are getting black colored copper oxide along with odorless and colorless carbon dioxide gas. So the reaction can be shown like this: CuCO3 on heating gives CuO, which is solid, and CO2, which is gas. Now non-metallic oxides. So metallic oxides can be prepared by three ways. Number one, by heating or without heating metals. Number two, by heating metal carbonates. Number three, by heating nitrates. So let's see how non-metallic oxides are formed and what is non-metallic oxides. Non-metallic oxides are formed when a non-metal is heated with oxygen. So how is non-metallic oxide formed? The same way metallic oxide is formed. Metallic oxide is also formed when it is heated without heating metals, but non-metallic oxides are formed when a non-metal is heated with oxygen. Non-metals like carbon, sulfur, phosphorus, nitrogen, hydrogen combine with oxygen to produce their respective oxides. You can see here carbon plus oxygen. That means carbon on heating with oxygen gives carbon dioxide, and then sulfur on heating with oxygen gives sulfur dioxide. S plus O2 gives SO2. Then nitrogen on heating with oxygen at a very high temperature gives nitric oxide, NO. Then hydrogen on heating with oxygen gives water, that is H2O. So most of the non-metallic oxides like carbon dioxide, sulfur dioxide, sulfur trioxide, phosphorus pentoxide and nitrogen dioxide are all acidic in nature. So metallic oxides are basic in nature, but there are few oxides which are amphoteric in nature. They are zinc oxide, aluminum oxide and lead oxides, which behave as basic oxides as well as acidic oxide. That means which can react with base as well as acid to form salt and water. But non-metallic oxides are all acidic in nature. They are not amphoteric. All acidic in nature. They turn moist blue litmus to red. They dissolve in water to produce respective acids. Carbon dioxide plus water gives carbonic acid. That means when you dissolve non-metallic oxides in water, then you will get acids. Whereas when you dissolve metal oxides in water, you will get base. So carbon dioxide plus water gives carbonic acid. Sulfur dioxide plus water gives sulfurous acid. Sulfur trioxide plus water gives sulfuric acid. And nitrogen dioxide plus water gives nitrous acid and nitric acid, mixture of acid. Mind you, this is very important. When you mix nitrogen dioxide with water, then you will get two acids, mixture of acids, nitrous acid as well as nitric acid. Acidic oxides reacts with bases and alkalis to produce salt and water. So again, these acidic oxides react with bases and alkalis to produce salt and water. Same thing when metallic oxides reacts with acid, then also we give salt and water. Similarly, acidic oxides when reacts with base and alkalis, they also give salt and water. This is neutralization reaction we have already done. So copper oxide, carbon dioxide when reacts with sodium hydroxide, we get potassium sulfite plus water. Similarly, sulfur dioxide, this is not sulfur dioxide, this is carbon dioxide. In A, what is that? Carbon dioxide, and B is sulfur dioxide. Sulfur dioxide when reacts with potassium hydroxide, then it gives potassium sulfite plus water. Non-metallic oxides like water, carbon monoxide, nitric oxide, nitrous oxide are neutral in nature. They do not change the color of indicators. So generally, non-metallic oxides, okay, they turn blue litmus paper to red, showing that they are acidic in nature. Whereas non-metallic oxides like water, carbon monoxide, nitric oxide, nitrous oxide are neutral in nature. They do not change the color of indicators. That means they are neutral. So if I ask you, give some example of neutral metallic oxides, then what will be your answer? Your answer will be water, carbon monoxide, nitric oxide, nitrous oxide and all. So this much for today. With this, we have finished chapter number 6, that is chemical reactions, and hope you will be doing exercise. You try exercise, I will also be helping you. So we have already done exercise 1 of this chapter, and now we'll be doing exercise 2 of this chapter. So this much for today. Thank you.